trust people can hear me. Or is there like a... okay. Hello, I'm going to talk today about API and UIs. My name is Duretti. I'm a senior engineer at Slack, and I work on the growth team, which again seems kind of like pretty ironic given how fast we've been growing. But at Slack, we think of the growth team as the team that guides you through inflection points. Whether when you visit slack.com, you decide to create a team, or if you decide after using Slack for a while you want to pay us. So like that, those kinds of decision points is kind of where the growth team kind of shines. We also maintain Slackbot, so sorry and you're welcome. You can find me on Twitter. My handle is my first name. I tweet about diversity and inclusion in tech, Beyonce, mostly jokes. So if that's what you're interested in, that's what I'm doing. For people who haven't heard of Slack, it is a group messaging app for teams. Officially, Slack's been around for about 2 years. I've been at Slack for a little over a year now. And you might have heard of us. Really quickly growing application. So a little bit more about Slack. We've got 2.3 million daily active users using our service. We've managed to convince 675,000 people to pay us for that, which is pretty cool. We've got over 365 employees, and we've also just opened a Melbourne office, so that's pretty great. And for the purpose of this talk, we're going to talk about APIs. But when I talk about APIs, I mean through the lens of a product company. And when I say product company, I mean a technology company that sells software, and the kind of software that that company sells is internet-based. So you might be thinking, what does this woman know about APIs? And to give you a little bit of my credentials, I've been working in the industry for about 7-8 years. For the last 7 of those, I was a front-end developer, and I was a consumer of APIs. And as such, I developed some very strong opinions about APIs and how they should be designed. I've also written and maintained APIs, and I've done that at Slack. I used to work on the platform team, and I've maintained our API infrastructure. And the reason that I care about this so much is when I joined Slack, I transitioned into being a back-end developer, and I thought I was just going to have to learn a whole bunch of new concepts. I was going to have to learn all kinds of new ideas and thoughts, and I realized that APIs and UIs are actually more similar than you might think. So that's what we're going to cover. We're going to cover a brief history lesson about APIs, what they are, this kind of nebulous interfaces and interface tautology. We're going to talk about that a little bit. And then we're also going to talk about the idea of developer experience. So we'll do a bit of a history lesson. We're going to go back in time and talk about common API design. API stands for Application Programming Interface, and they've been around for ages. And it's the way that you interact with a set of codified principles against other people's code. So in the past, they've been called libraries. And anytime you set up rules around how you want your code to be used by other people, you're writing an API. So we are going to flash back. We're going to go back in time to the far past, to the 90s. And we're going to talk about SOAP. SOAP stands for Simple Object Access Protocol. It's the dominant API design at the time. It's a document style model, and we'll get into what document style means here in a second. But it came out of Microsoft, and like everything that came out of Microsoft in the late 90s, it was needlessly complicated. Furthermore, it was a spec, so the implementation that they want you to do is very rigid and has expected rules and behaviors laid out. So SOAP requests are in what's called a SOAP envelope, which is an optional header and a body and kind of like a container. And you can think of that as a pizza. So if you're making a pizza, you have to have a crust, which would be considered the envelope. You would need to have a body, which would be the sauce and the cheese, that's important for a pizza. And then the optional header would be your toppings. In this case, basil, because I'm a vegetarian and I don't eat meat. So what's good about this system? SOAP gets a bad rap, but it is really good because it has well-structured responses and requests, and you can layer security on top. It's transport agnostic, so you don't actually need to do anything over HTTP if you don't want to. It's really good at security, and it's like bank level stuff, so it does have some like good things about it. It also has some cons. What is this even? I don't know, what is this? This is ridiculous. This is like a basic envelope, and it's really verbose. It's XML based, and anyone that's tried to parse XML and JavaScript knows what it's like to want to blind yourself. It's very heavyweight. So SOAP ended up being too opinionated, so we're looking for other ways to do API stuff. Roy Fielding comes up with REST in his dissertation in like 2000. And I wasn't doing anything this useful in 2000, I could tell you that. He comes up with this idea of an architectural design, which you can use HTTP verbs like get, post, put, patch to do kind of the updating of like the system that you want. The cool thing about it is that it uses URLs, which is kind of like the currency of the web, which is really great. And if you go from kind of constructing these really kind of verbose XML documents to putting this into a URL bar. And this is way better. So much simpler. Fielding laid out a bunch of other stuff in his dissertation, but REST is not it's an architectural style and not a spec. So instead, the spec part gets pushed down into the HTTP protocol. So we use that to relay our messages, and we let the browsers worry about how to like ferry things around, and we can be concerned with like how we want our returns to look like. So pros, so much better. So simpler, more flexibility, it's portable, easy to modify, and then so that's great. And then some of the cons are security and latency. Since everything is going through a browser, you have to be careful about how you transmit certain sensitive information. For instance, passwords and clear text. You don't necessarily get the kind of security that you'd want. Also, latency is a thing if you're using a browser, but we don't have to worry about that. That's more of like concerns for like the browser makers. Ultimately, the cognitive load of like using REST style is so much lower that this is a trade that we end up making. And around at the same time, JSON is becoming more and more popular. JavaScript's very own Dumbledore, Douglas Crockford, is like doing all kinds of like advocacy for JSON. He puts up a website. It helps that JSON is JavaScript, which makes it easier to parse and like less likely that you'll eat insulet because you're so upset with all of the parsing of the XML. So we go from something that's like totally bananas like this to this, which is like, this is like way simple. This is so much easier. So this is why it begins to win out. Also around this time, like in the early 2000s, we start seeing the rise of like social networks like Flickr and Twitter and Facebook, and we start to want to have increased connectivity between our various services. So websites start to look like this, where people are embedding like whole Twitter feeds or Flickr feeds or like into their websites. And we're also seeing it become kind of like the backbone of the internet. Like modern software, I'd make the argument, is built on top of APIs. We want to be able to embed various services into the things we make, like embedding Google Maps into an application or a website. It's very, very useful. Okay. That's kind of API design, like as we're going to be continuing to discuss it. So we're going to move on to the very nebulous, an interface is an interface. What does that mean? I keep saying the word interface. What am I talking about? An interface is more than how something is presented. Typically, when we're in like computer science, when we talk about an interface, we talk about the boundary or the edge between two systems. So it's like where two components meet. If you're front end, you're back end, in the middle, you've got an API. So that's kind of what we're talking about when we talk about interfaces. So what's important for an interface to do? clarity is like the #1 most important thing that your interface can do. It needs to communicate clearly. Secondly, it needs to be well-designed and modular. The kind of well-designed code I'm talking about, interface I'm talking about, reduces cognitive load, much like a well-designed front end would. It'd be intuitive. Like, good design is 99% invisible, right? And so an intuitive interface is easily navigated, and this kind of thing, this is kind of a gotcha because this is easier said than done. It takes a lot of time and effort and energy to make something that's intuitive. But luckily, we're building software that's on the internet, so we can easily iterate. But at the end of the day, like, good interfaces are empathetic. And what I mean by that is that they take your needs into consideration. They feel well thought out. They feel your pain points and try to address them. Empathy means kind of feeling with your customer base and putting yourself in their position and trying to solve like an actual problem. I super care about empathy in software development and how we might bring it into our processes. I've talked about this in the past in a talk called Empathy-Driven Development. If you're interested in talking about empathy and the development process, come get at me later. This is something I will talk your ear off forever. So, aside over. Interfaces are universal. So like, there's no difference between an interface you click around in a front end in a browser and what's returned programmatically in an API, because good interfaces have very specific qualities, like we talked about. They're consistent, they're delightful, they take your needs into consideration, and they're also modular. Okay, so now we know kind of like what an interface is, what like we consider to be like good interface design, what an API is. We are going to talk about developer experience. Whew. Okay, so what is a developer experience? This is kind of like the argument I would make. User experience is to user interfaces as developer experiences are to APIs. User experience is defined as being the overall experience of using a website or a user interface. Developer experience, on the other hand, would be programming against an API and like how that feels. And in both cases, we are chiefly interested in how easy or pleasing it is to use these kinds of systems. So firstly, we want it to be consistent. The hallmark of a good user experience is that things behave in the way that you expect them to behave. And this is kind of twofold because, one, people expect a certain amount of, like, expend a certain amount of mental energy learning your system. So if you can anticipate the actions people will take, it's nice because like that can be seen as very touching. So we're going to look at a couple examples of like good and bad versions of this. So Seamless is a food delivery service in the States. In 2013, they merged with Grubhub, and last year they released, they worked for a long time and released like a combination of their two backends and released a new UI. And the reaction was kind of unreal. It was a total like, who moved my cheese scenario? You know, customers had gotten used to the flow, and like Grubhub was like, we did this better, cool thing. But people were like used to like, when I want to order a thing, I do these 4 things and like I'm done. And so that's really great. For the user who's already learned that system, but if you change it, like you kind of get a lot of like backlash. And people learn how you go from point A to point B despite the inefficiencies. So what does a developer version of this look like? It looks like this. Software engineers like being verbose on the internet, so there's like Medium screeds about like how things have changed. This is a Medium post by Matthew Rothenberg. He has this project called Emoji Tracker. And Emoji Tracker is a real-time visualization of all the emoji being used on Twitter. So this is kind of what it looks like. It streams live events from Twitter, and then it pulls out all of the emojis, and it does a count. If you look at it live, it's totally disorienting because it's like updating, and there's highlights with like the color of each eventual. I didn't want to put that in because he actually has like a warning about epilepsy, like not to look at it. So you can do that in your spare time, but like that's kind of like that's the rapid pace at which it's updating. So if you click on the peace sign, which is my favorite, You can see like a list of tweets that come back, just some information about like, the shorthand, the colon syntax, and the code for how you can get it. So this is like a cool side project, to use Twitter in this way. So why is he writing like a huge Medium post about this? It turns out it's because Twitter is revoking his access to the streaming API, and he needs it to populate his emoji tracker. This isn't a consistent experience for a developer, and nor does it strive to like develop or to like delight the developer, right? This is like kind of sucks that you built this whole project and people are using it, and now it's being like spun down. And so we're seeing an interesting thing right now with like APIs is that they're not necessarily permanent. Just because a company makes an API available doesn't mean that it's going to be available in the future or in the same version, right? And so, or it might be like available in a different way. And Twitter and LinkedIn have like recently kind of like restricted their access for people to like their APIs. So one thing we can consider is that like familiarity with these systems is a more powerful concept than intuition. We want to make software and the software experiences feel more intuitive, but it doesn't serve the people who already know how to use a thing today or are already relying on existing systems. And that's why changes to these systems feel like really, really jarring, especially without a heads up, where it's just sort of like, here's an email, we're restricting your access. Delight is a hallmark of a good user experience. It's what engenders love of a service and delight of your tool. It's kind of unreal that people like Slack, which is enterprise software. But we're going to look at some examples of like how we are like delighting our users. This is the shouty rooster. This is something that gets triggered when you do an @channel and there's people in various time zones, and an @channel will send notifications out to anybody who's connected. So it'll either send you a push notification or send you an email, and it's not, and like irregardless of like if you're in the same room or not. And so this thing tries to catch you if you're like sending this out to like people who are like on the other side of the world and they might be asleep. And so this is like a way that that we're trying to get ahead of like that kind of a thing. This is documentation from a company called Auth0, and they do authentication and authorization for developers. And the developer experience is like core to their business, and they do some really delightful things. One of the things that I think is really great about this company is that after you go through and pick your development stack, you say like, I'm writing in JavaScript and my backend is this, and they kind of like point you to the right documentation. They give you the option of trying out their API in Postman. And to me, that's like so amazing because Postman is a fantastic tool, and it lets you create and send HTTP requests, and then it records those requests so that you can do them again later, so you're not constantly like in the terminal looking at curl, like figuring out what did I change, what did I do, what do I want to modify here. And it's a really great plugin. It's in Chrome, so I definitely recommend that people try to check it out. So that's the delight portion. Idempotent. Idempotent is a fun computer science concept that comes out of mathematics, and it's the idea that you should be able to over and over do the same action and get the same response. So let's say we're designing a CRUD, kind of like RESTful API that stores a collection of treats. And when you do a get to this API method, it should do the same thing every time, which is like return a list of all the treats that you've saved in your database. When you do a post, it should, barring any kind of like latency or network issues, save your treat to the database. And it should reliably create those new records over and over again. Deletion is a little interesting. It should delete the record one time, but if you do it again, it should again tell you like you deleted something. And you should be able to call the delete on this record, this particular row, and have it tell you that this thing is deleted. A lot of times we do that through updating a timestamp, so it should tell you that thing. Another thing that's important to the developer experience is the idea of reliability. And I know that Gary talked about this a little bit earlier today, but when I'm talking about reliability, I'm talking less so about is your API up and running, but more like, do we return the same kinds of objects everywhere? So to go back to our snacks endpoint, say we want to get all of the snacks in our card API, we want to have a certain response. And let's say that this is our response. It's just sort of like, okay, here's one row, here's another row, and I have some hot Cheetos that I like, and they're junky foods, and I have some mints, and they're candies, and this is great. And this is kind of what my database would look like. Let's say now that I want all of the snacks for a particular user. This shouldn't be what's response, but this shouldn't be the response. Like this is kind of, it doesn't look like the previous response that we got. And we want to make sure that like in every case that we're interested in, like say like a snack object, the snack object looks the same. So this is what a better response would look like. And in any case that you need your object, it should be the same in every single place. So documentation is also like a super key important part of API work. For me, if there's not documentation, you don't get to release the thing. Documentation is like the contract that you make with the developers using your API. It lays out the behavior, and it's your interaction layer, especially with like API stuff. This is a screenshot of Stripe's API page. And their API is like super, super excellent. And one of the reasons it's so good is because its primary use case is to be an API. It's always been kind of like, how do you do credit card processing for developers? That's kind of just been their thing, and they've been really good at executing on like the one thing that they're good at. And one thing I think is like really, really great about their API is that they'll let you try out responses in the most popular languages, and they give you like a fake authentication token, and you're off to the races. You can curl or put in Postman and do whatever you want to do, and it lowers the bar to entry so much. I guess you were wondering when I would talk about the Slack API. This is the Slack API. This is the documentation page for a particular endpoint, which is our API tester endpoint. It's very Inception-y. We have like an endpoint about how to test our API. But it's one of my favorite pages, and it allows you to enter in and see how the API will respond back to you. When I first joined Slack, this was the page I used the most. It taught me a lot of things about how Slack thinks about stuff. Firstly, we'll notice that it always returns a top-level OK, which is true or false, about if our systems actually were able to complete the request that you made. And then if it's false, it'll return like an error message, and then some further stuff about like what you passed in. But if it's true, it will return a top level OK true. And the interesting thing about this is that it means that every Slack response that you do to our API returns an OK 200, which is kind of weird. But then we pass all the error stuff into this error blob, which then you can parse. So why do we do that? Like, why would we return like a 200 every single time? Like that seems to fly in the face of kind of like known conventions. Like, why would we do that? It seems pretty strange. And the reason we do that is that the Slack API is totally like a for us, by us thing. We built our API for us to use, and we built it for our mobile, desktop, and web teams. And that means that we needed a way to throw errors that wouldn't totally break our application. One of the reasons that people use Slack is that it kind of works generally all of the time. So if an error was thrown and the application stopped working, it wouldn't behoove us, right? And so one thing that's interesting here is that we can see like the original architecture or the original design thinking of like what went into making this, like making this decision. And I find that super interesting. Okay, next item. Modularity. Modularity is really important. A decent interface is made up of reusable modules. In this case, a module, what I mean is like a small, distinct piece that can be combined with other small, distinct pieces to combine like a to make a larger whole, which will be our interface. So we're going to look at an example pulled from the Slack interface. This is the channel membership list in Slack, and this is for one of the rooms I'm in. This is the developer channel for the growth team. And the idea of the channel list is totally modular. Each channel has one. Each channel displays the specific channel information. And in this case, we're looking at the number of members in the channel and if the people in the channel are online or not. So what goes into making this kind of a thing? So in order to populate our channel membership list, we need to do a GET request to channel.info. This is a real API method, and it provides us with the information that we need to populate parts of our information list. So looking at our JSON response, we get back an ID, we get back the name, we get back if it's archived or not, which means that you can actually view it, if it's general, and then kind of an array of members, the topic, purpose, all this kind of stuff. So looking back at our list, we can see how that information from the JSON is applied. We can see our name, which was sent back, and we can see our members. However, channel.info doesn't give us any information about the current state of individuals in the channel. So let's look into that a bit more. So this is me, this is my face. This is what my picture looks like in Slack today. And it shows my name, my picture, and if I'm logged into Slack or not. And so in order to get that information, we do a call to users.getPresence. And it'll return my name, what my avatar is, and a bunch of information about me specifically. So looking at the response, we see that top level OK true. That means that Slack, our systems were able to finished running. And we can see my first name, my last name, my email, and then all of our image avatars that are stored in S3. But it doesn't do anything for showing if I'm logged into Slack or not. So that's not great. We don't have everything we need. So for that, we need to do another API request. We would do users.getPresence, and it'll show whether I'm logged into Slack or not. So this is what that response looks like. It's pretty useful. So then, if we revisit this, this piece, this modular component, we can see the profile bits, and we can see that I'm actually logged in. So zooming out now to the general channel membership, we can see all of the information and how that all came together. Cool. So the Slack API and the Slack UI kind of fit together like a hand in the glove. And it makes it easy so that we can tightly integrate with one another, and it improves each interface. So that's what I kind of mean about generally how a good UI can be based on a good API. So what did we learn? Interfaces are more than just how a thing is presented, it's how it's organized. So it's more than just the presentation layer. Good interfaces are empathetic as all get out. Tell your friends. And they are modular, reusable, and consistent. Lots of people made this talk possible, so I wanted to thank my colleagues and anybody who listened to an early version of this talk. And if any of these ideas interested you, Slack is hiring in a big way, so we have a jobs page, check it out. Thanks for listening. That's all I've got.